Good day. So for week 2, day 1, we're gonna discuss about the trigonometric functions as well as the Pythagorean theorem. And then on the last part, we have the special triangles and summary of values if we have sine, cosine, tangent, and then the special angles. Um, in which we also discussed, well, the special angles that we discussed in week 1, day 2. Okay. So for the trigonometric functions, if you can remember the 6 trigonometric functions, we have the sine, cosine, tangent, cosecant, secant, and the cotangent. So with the trigonometric functions, so we have to consider a right triangle. A right triangle in which it has vertices, 3 vertices. We have A, B, and C. So just a reminder, when it comes to the naming of the vertices, well, there's no particular order. Also, there are no specific letters to be used because there are triangles in which the letters used are RST, MNO, and many others. Okay? But when it comes to the naming of the sides of the right triangle, the label or the name will depend on the vertices. Okay? So for example, if we have this side A, you would notice that side A is opposite vertex A. Then we have side B, which is opposite vertex B. And then we have side C opposite vertex C. So if ever that we're not gonna use the ABC, so you can use the R, the S, the T. If that is the case, this A will become small r, so on and so forth. It is also possible that if you would like to use the ABC, but then the order can be different, um, just like, well, if you would like your B here, then your A here, and then C here. So it means that if this is your vertex B, the side opposite it will be small b. That is how you're going to name the side. So the vertices are important, the names of the vertices, because again, the names of the sides will depend on the vertices. As well as, well, when it comes to the angle. Okay, so I'll remove the ratings. So when it comes to the angle, if we have your vertex A, this will become your alpha. If this is vertex B, this is your beta. And if it is vertex C, this is the gamma. Um, the angles are being named if ever, so this way, being named this way, if ever that there are more than 2 angles shown in the triangle. Okay, or there are, for example, why did I say more than 2? Because as what you can see with the right triangle, the right angle is already visible. So you already have one. And usually the right angle is not anymore labeled because it is automatic once you see this symbol here. So what we can have is the alpha or the beta. But then usually if we only have one one angle shown, so either on A or B, so we can see the use of the theta. Okay? But then if you would like to use the beta, it is okay as long as be sure that that beta is on B. Or well, you can make use any other symbols. That's it. So going back to the right triangle, this right triangle, remember we have the 3 sides of the right triangle. the opposite, adjacent, and hypotenuse. So in determining these three, it should be clear with you, actually, not only, so determining the three, so the first two, opposite and adjacent, you have to consider the theta. Then the hypotenuse, so in determining this, of course, we know that the hypotenuse is the longest. So looking at our right triangle here, the longest is the C. This is our hypotenuse. When it comes to the opposite, you take a look at the theta, okay? The side that is opposite the theta is the B. So this is our opposite. And the side adjacent theta, when we say adjacent, it is beside. Again, it is beside. So the theta beside, or the side that is beside the theta is A. This is our adjacent. Okay. So what if that the theta is on A? So same concept. If the theta is on A, therefore A would be the opposite and B would be the adjacent. That is when the theta is on A. So how can that be? So I'll erase the writings as well as the theta here. Okay. So again, example, when your theta is on A. When the theta is on A, so this time, you're gonna determine the sides. So of course, C is the longest. So this is your hypotenuse, the same. And then as what you can see, the side that is opposite this theta is A. So A is the opposite. And then the side that is beside B, or the side that is beside the theta is B. So this is your adjacent. Okay? Next. So on the next slide, we have here the sine. So sine theta, if you can remember, in terms of side, it is what? So sine theta equals to opposite over hypotenuse. In the PowerPoint, I included here a formula which is based on the triangle that you can see on the left. Okay? Since we have the opposite, which is denoted by B, and the adjacent, which is denoted by A. So here you can see that sine theta are rather, and C is denoted by and C is for the hypotenuse. So you can see that for sine theta, we have B over C, or opposite over the hypotenuse. But remember, it will depend on the placement of your theta. If your theta will already be on the upper portion, well, the lettering here, the letters here would be different. So if I were you, I would suggest that you take note of this one. The sine theta equals to opposite over hypotenuse. Because if you know it, no matter where the theta is, you can solve for the sine theta. And you won't rely on letters. Okay? Because letters can be changed. The theta can be different. For the cosine theta, so cosine theta is adjacent over the hypotenuse. So again, what you need to remember is this one, the cosine theta equals to adjacent over hypotenuse. Same with tangent theta. So opposite over the adjacent. So take note of this. We also have cosecant theta. Cosecant theta is the reciprocal of sine theta. If sine theta is opposite over the hypotenuse, so the reciprocal is hypotenuse over the opposite, and that is cosecant theta. Next, the secant theta is the reciprocal of cosine theta. So if cosine theta is adjacent over the hypotenuse, the reciprocal is hypotenuse over adjacent, which is secant theta. Then we do have the last one, the reciprocal of tangent, which is cotangent. If tangent is opposite over adjacent, therefore, cotangent as its reciprocal will be adjacent over the opposite. So those are the 6 trigonometric functions. For the example, I will provide an example after the discussion of the Pythagorean theorem. Pythagorean theorem is described as the sum of the squares of the two sides of a right triangle, which is equal to the square of the sum of the longest side. In formula, it is a squared plus b squared equals to c squared. So in the Pythagorean theorem, the two sides that are being mentioned here are the opposite and adjacent sides. And then the longest side is the hypotenuse. So this formula a squared plus b squared equals to c squared, this is actually known worldwide. So even if you are from another country, as long as you studied trigonometry, you know that this is the formula of the Pythagorean theorem. But then again, since the letters may be changed, okay, and as well as the theta can also be changed. So it is better if you're just gonna memorize, well, this one. So we have opposite squared. Remember, it is the sum of the squares of the two sides. So we have opposite squared plus adjacent squared equals to the square of the longest side, hypotenuse. So that is hypotenuse squared. This can also be written the other way. So we have adjacent squared plus opposite squared equals to hypotenuse squared. They are just the same. Okay? Since the operation is addition, so they can be the same. So you can use either of the two. This is safe to use, especially when the given triangle doesn't have, well, don't have letters on the vertices. For example, you're just given the measurement of the sides of the triangle, so this is safer to use. But then it is up to you. If you find it comfortable to use the a squared plus b squared equals to c squared, you may do so. If not, you can make use of opposite, adjacent, and hypotenuse. Okay? So, as what I said a while ago, we're gonna have the example already. So, I'll switch to the black screen. So, for the first example, so say that we have a right triangle. Okay, so this is the right triangle in which the given measures are 5, and then we have 2. So since this is a right triangle, so we have to include this symbol. And then the theta here is on the lower portion. So the first thing that we need to do is, well, as what you can see, so we only have two parts here in which the measurements are given. So say that we are gonna put x here. Okay. So if we would like to solve for the x given two sides, remember class, remember the Pythagorean, this is used if you are given two sides. Okay, two sides are given. Two sides are given and then one side is unknown. So in this case, we can use the Pythagorean in determining the measurement of x because 5 and 2 are given and then one side is unknown. if you try to consider the trigonometric functions, well, remember that in the trigonometric function, so for example, sine theta, and then equals to the fraction of the two sides or the ratio of the two sides. If the theta do not have a value or a measurement, and then, well, if you would like to solve for this x, you should try to think that the theta should be given. And then one side is also given. So you can make use of, or you can solve for this x. Okay, later I'm going to show it to you. So when are you going to use the trigonometric function here? Okay, so again, since we do have two sides given and one side is unknown, it is better to solve first for the unknown side, especially if it is being asked. And that is by, by the Pythagorean theorem. Okay, so before we apply the Pythagorean theorem, so let us identify first the parts or the sides. So since this is the theta in this portion, so opposite it is the 5. So this is our opposite. And then beside it is 2, which is the adjacent. And then x is considered to be the longest. It is the hypotenuse. Another thing that you have to consider in determining the hypotenuse is that the hypotenuse should be opposite the 90-degree angle. Okay, so as what you can see, hypotenuse is opposite the 90-degree angle. Okay, now, so let us solve. So I'll erase the writings on the right side. So let us use the Pythagorean theorem, opposite squared plus adjacent squared equals to hypotenuse squared. Okay. Again, if you would like to use the a squared plus b squared equals to c squared, you may do so. So you're just going to assign letters on the vertices. But to make it easier or faster, you just determine the opposite, adjacent, and hypotenuse, then make use of this formula. But then it's up to you. So in which one are you comfortable? Okay, or you find it easier to use. So what we need in our problem in order to solve it is just the hypotenuse. So in the Pythagorean, our hypotenuse is on the right side. So we do not need the square. What we need is hypotenuse alone. Okay? So what we need to do here is to derive. So how are we gonna derive? So let us have the derived formula. So in deriving the formula, this means that you need to have, or you need to write the unknown in one side only, and it should be alone. It will depend on the unknown. So just like this, it is only hypotenuse and it doesn't have the square. So we need to find a way how we can remove this that square. Okay. So first, let us since this is equation, so we can write it this way. So equation hypotenuse squared equals to opposite squared. So you just write the one on the left, okay, to the right, and vice versa, plus adjacent squared. And again, what we need is hypotenuse only. Hypotenuse. We do not need the square. So if you can remember, in removing the square, I'll just rewrite it again. In removing the square, what you can apply is the, extracting the square root. So in extracting the square root, you have to put square root on both sides. Why? Since this is equal, this is an equation, what you do on the left, you also do on the right. So the square of the hypotenuse, you can remove the said square. So you have hypotenuse only. Hypotenuse. Okay? Then on the right side, remember, you cannot cancel the power 2 and the radical because you have the operation addition. Cancellation is only allowed if you have a single term. Or if you have operation, it should be multiplication or division. If the operation is addition or subtraction, you cannot cancel. Remember that. If you have um, terms or expression just like this, okay, if you have two terms, you cannot cancel it. So what you need to do is just to copy it. So that is square root of opposite squared plus adjacent squared. Okay? So as what you can see, we are able to have on one side the unknown. So it is alone. So therefore, this is our derived formula. This is our derived formula. And we're gonna use this later to solve the triangle. Okay, now, I'll erase this portion. Then I'll rewrite the derived formula. So the derived formula again is hypotenuse equals the square root of opposite squared plus adjacent squared. Okay, now you're going to substitute based on what you can see on the illustration. So the hypotenuse is denoted by x equals square root of, so the opposite, we have 5. So squaring it, and then adjacent is 2. You square it also. So with your calculator, the answer here, so you use your calculator or you can do it manually. That is square root of 25 plus 4. It is square root of 29. Okay? And this is your answer. If ever that in the problem, there's a given unit, say this is 5 meters and this is 2 meters. So your answer should have the unit also. So if it is in meter, so you can, well, you can convert it. So with your calculator, square root of 29. So it is 5.39. So this is also the same, 5.39. Then you include it, okay? That is if there's a unit. If there's no unit, your answer in radical or fraction is okay. Okay. Next. So let us now have the trigonometric functions. Okay, trigonometric functions with the same given. So since we're able to solve for x, which is square root of 29. So I'll remove the other writings. So the first one that we are going to solve in the trigonometric function is the sine. But then remember the SOHCAHTOA first. So SOHCAHTOA. So in SOHCAHTOA, S stands for sine. So you put here the theta. C stands for cosine theta. And then T stands for tangent theta. Then the O. The O is opposite. H is hypotenuse. So, since our formula for the sine is sine theta equals, okay, you put equals, then you just put here the slash, okay, in between the opposite and then the hypotenuse. You already have the formula for the sine theta. This is the formula. And then for cosine, so since A is adjacent and each is hypotenuse, so the same. So you just complete this by putting equals and then a slash in between the adjacent and the hypotenuse, then you have already the formula. So the formula for cosine is cosine theta equals to adjacent over the hypotenuse. For the tangent, tangent is opposite for the O and A is adjacent. So the same. You just put equal sign and then put a slash in between opposite and adjacent, and then you already have the formula for tangent. That's it. So tangent theta is opposite over adjacent. Then just remember the reciprocals. So for the reciprocals, so the reciprocal of sine is cosecant theta. So if in sine theta, the opposite is in the numerator, this time you're gonna put the opposite in the denominator and hypotenuse in the numerator. So this is the reciprocal of sine. For cosine, the reciprocal is secant theta. And if in cosine, adjacent is in the numerator, for secant, adjacent is in the denominator, with hypotenuse on the numerator. This is secant. Then reciprocal of tangent is cotangent theta. So if opposite is on the numerator in tangent, for cotangent, it is already in the denominator with adjacent in the numerator. This is cotangent theta. Adjacent over opposite. Okay, next. So adjacent over opposite. Next. So we're gonna continue solving. So I'll just erase this. So in solving this, first, so sine theta, we know that sine theta is opposite over the hypotenuse. And then substituting based on our triangle, our opposite is 5. The hypotenuse is square root of 29. Okay. Remember, if you have a fraction in which the denominator has radical, you have to rationalize this. So square root of 29 over square root of 29. You will be given the answer, or your answer would be 5 square root of 29 over 29. This is the final answer for sine theta. By the way, class, if you are not sure with rationalization, you can try to check your answer in the calculator. So what you can do, you input the 5 over square root of 29, you press the equal sign, the result on the screen will be 5 square root of 29 over 29. Next, cosine theta. Cosine theta is adjacent over the hypotenuse. So substituting, adjacent is 2, the hypotenuse is square root of 29. So since the fraction has a numerator with radical, you're gonna do the same. So rationalize it. So cosine theta is 2 square root of 29 over 29. This is the answer. Okay, next. We can now already solve for the tangent. Tangent theta is opposite over the adjacent. So substituting, opposite is 5, adjacent is 2. 5 over 2 cannot be reduced anymore. So this will be your final answer, 5 halves. Okay? Then you can try to solve cotangent first or secant or cosecant when it comes to reciprocals. No particular order. So see if you would like to solve for cotangent. Okay, so cotangent is adjacent over the opposite. So substituting, adjacent is 2, opposite is 5. So 2 over 5, this is already the answer. Okay, that's it. And then I'll erase this portion to solve for the other two reciprocals. Okay, so the next reciprocal that we can solve, so again, it is up to you which one would you like to solve first in the reciprocal. So cotangent, we can have secant theta. So secant theta is equal to hypotenuse over the adjacent. And substituting, hypotenuse is square root of 9, square root of 29 over adjacent of 2. So this cannot be reduced anymore, nothing to cancel. So this will be the answer. And then another reciprocal is the cosecant theta, which is hypotenuse over the opposite. So substituting, we have hypotenuse of square root of 29 over opposite, which is 5. Again, nothing to cancel. So therefore, this is the final answer. So just do not forget to box your final answer. So that's it. Okay, so we can have the next example. So I will clear the writings on the screen. Okay. So another example is so a right triangle. Oh, this is a right triangle. Given the measures of 6 and 10, and then the base is unknown with theta. Okay, this time theta is on the upper portion. So you can put the data inside the curve or outside. It doesn't matter. Okay. So now, again, the first thing that we need to do is to determine first the x by using the Pythagorean theorem because we are given two sides and one side. So first, identify which is the opposite. So the opposite of the theta is x. The adjacent is 6. And then the hypotenuse is 10. Why? Because 10 is opposite the 90-degree angle. Okay, now let us solve for the x. So for our formula, remember we have opposite squared plus adjacent squared equals to hypotenuse squared. And in our problem, what we need is opposite alone. So opposite in our formula is here. So we need to get rid of the adjacent squared, possible by transferring it to the other side, as well as the square, the power of the opposite. Okay, so how are we gonna do it? So first, so you copy this opposite squared. Since we do not need the adjacent squared on this side because it is not, well, because we need to come up with a formula or equation in which opposite will be alone on one side. So we can move or transpose adjacent how? Copy first what is on the right, so hypotenuse squared, and then move here the adjacent squared. So if you can remember, when you transpose, so the operation will change. So this will become minus. Next, since we need to remove the square on the hypotenuse, or rather the opposite, okay, the opposite, so we can apply the extraction of square root. Okay? Or we can apply square root. So this time we can already cancel. So this is opposite. And then on the right side, remember, since we do have the operation subtraction, so we cannot cancel. You're just going to copy it. So that is the square root of hypotenuse squared minus the adjacent squared. Okay? So this is actually the derived formula. Derived formula. And then the next thing that we are going to do, we are already going to substitute. So from our given triangle, the opposite is denoted by x, so equals, and then square root of. Hypotenuse is 10, and then the adjacent is 6. So if you try to compute this, so finalize your answer, the answer here would be 8. So that is the measure of x. So x is 8. That's it. So we already know the measures of the three sides. Now, we can apply here the trigonometric functions. So I'll just erase this. So again, trigonometric functions, let us start with the sine theta. So sine theta is opposite over the hypotenuse. And then let us substitute. The opposite is 8. Hypotenuse is 10. So reduce this. We do have 4/5. This is sine theta. Then we can have cosine theta, which is adjacent over the hypotenuse. So substituting, we have 6/10. So cosine theta is 3/5. Next, we can have here the tangent theta. Tangent theta is opposite over the adjacent. So substituting, we have 8/6. We can reduce this. So this is 4/3. Then for the reciprocal, so again, no particular order for the reciprocals. So if you like to start with the cosecant, so we can do it. So cosecant is hypotenuse over the opposite. So substituting, hypotenuse is 10. The opposite is 8. So cosecant theta is 5/4. Okay? Next. So I'll erase the writings on the right so that we can have the other two reciprocal functions. Okay. So we can have secant theta. So secant theta is hypotenuse over the adjacent. So substituting, our hypotenuse is 10, adjacent is 6. Again. So okay, so let us solve for the secant theta. So secant is hypotenuse over the adjacent. So substituting, the hypotenuse is 10, the adjacent is 6. So secant theta is 5/3. And then for cosecant is done, so we have the cotangent. Okay, cotangent theta is adjacent over opposite. So substituting adjacent is 6, opposite is 8, therefore cotangent theta is 3/4. Okay, so we'll go back to the PowerPoint. So these are the 6 trigonometric functions. And then prior this, we solve for x using the Pythagorean theorem. Okay, so this is to show to you in this slide the right triangle, although I already explained this while ago. So if we have the right triangle, so we do have the vertices, so A, B, and C, and then naming the sides based on the vertices. So we have side A, opposite vertex A, side B, opposite vertex B, and then side C, opposite vertex C. And then for the angles, if we have vertex A, we can use alpha. If we have vertex B, we can use beta, and for C, we can use the gamma. Again, if one angle is only shown in the right triangle, so you can use theta. Now, for the special triangles, so the first special triangle is the 30, 60, 90 triangle. When we say 30, 60, 90, these three numbers are actually the measurements of the three angles of the triangle. Remember that always remember the sum of the angles of a triangle is 180 degrees. So that is for whatever triangle you have, whether equilateral, right, iscaline. So you can see that when you add 30, 60, and 90, the sum is 180. But then how can we have a 30, 60, 90 triangle? So that is if you have an equilateral triangle. The equilateral triangle has equal sides. Not only equal sides, they do also, well, it also has equal angles of 30 degrees. So, or rather, that is 60. I'll just write it, okay? Before we cut the triangle, okay? So, having equal sides and having equal angles of 60 degrees. So, also on the upper portion, this is 60. So how can we have the 30, 60, and 90? So when you split the triangle into two, okay, splitting it into two, so you can see that this 60, now it will become 30. Okay, 30 degrees. The other one is also 30. And on this portion, we do have 90. This is also 90. So we have the 30, 60, 90 triangle. With the equilateral triangle, we can come up with two triangles. Okay, we do have here two triangles. So we have here triangle 1 and then triangle 2. Next, in dividing this triangle, so since the base measures S, so the base of one of the triangles will be S over 2. And applying the Pythagorean theorem, well, the red broken line here is actually one of the legs of the right triangle, and it should also be labeled or named. And it is square root of 3s over 2. That is by Pythagorean theorem. Class, remember, no need to prove this. Okay, no need to prove this. This is only showing to you by illustration how can we come up with a 30, 60, 90 triangle if we have an equilateral triangle. Okay, next. The next triangle is the 45, 45, 90 triangle. So how can we have the said triangle? So if you have a square, so the square has equal sides, and then you're gonna cut it diagonally. Since the triangle can be well, the triangle that has the angles 45, 45, and 90 can already be seen, okay, in this square. How? So how can it be seen? So you have here 90 degrees. So if this portion is also 90, it means that splitting it, we do have 45 and then 45. Then also the same with this portion. So this is 90. When you split it, you have 45 and 45. This is also a 90. So we are able to come up with two triangles here. Okay? So the 45, 45, and 90 triangle. So we do have here square root of 2. That is after determining the label for this by Pythagorean theorem. Okay? Pythagorean theorem. So in Pythagorean, so we do have here well, the two sides S and another S. So you just well, you just assign one theta. Then identify which is the opposite, adjacent, and hypotenuse. Then you'll come up with the square root of 2s. Same solution for the other special triangle. The next slide, we have the summary of values. In the summary of values, well, how do you use this table? Although no need to memorize because if you are using a calculator, so you can already have the answer. So we have here the angle, okay? Then these are the trigonometric functions. So for example, if you will be asked, so what is sine 30 degrees? If you will be asked to evaluate. When we say evaluate, you need to, well, you need to solve, okay? So sine 30 degrees. So in your calculator, you can input sine 30 degrees. But then by the way, remember, your calculator should be in degree mode. So degree mode. Okay? Degree mode. Usually in the calculator, you cannot see the DEG. What you can see is the D. Another mode that you can have there is the rad, the radian. But then for this angle, since you can see that this is in degree measure, so what we need is degree mode. Okay, going back. So when you input in your calculator sine 30 degrees, you press the equal sign, it will give you the answer of 1/2. Okay? And that answer is this one. Okay? So sine 30 degrees, press the equal sign, it is 1/2 or 0.5. Another, if you would like to try tangent, then 60 degrees. Okay? So the intersection of this is square root of 3. It means that when you input in your calculator tangent of 60 degrees, your answer is square root of 3. Okay? So there is an activity in the LMS, so please answer it before the deadline, on or before the deadline. Okay, so this ends the lesson for week 2, day 1. Thank you.